Uh, my name is Mohamad Harris, and the purpose of our interview is for our PHY 3200 assignment, which require us to interview you about the field of your research and all of it. So, if you guys may have not known, Professor Chen Ken is actually an expertise in superconductor and nanomaterial. Is that right? Okay. So, without further ado, I think we should start the interview now. So, Bukhari, do you want to start asking question first?
Oh yeah. Shall I start first? Okay, first, my name is Muhammad Ramlan, and from the Bachelor of Physics. So, I would like to ask the first question. I think it's the same question as the group before, which is what methodology are used for research? What method that doctor used for your last research, doctor?
Doctor, you forgot to unmute your mic, doctor.
Oh, sorry about that. Yeah, so the question is, what kind of materials I'm working with? Yeah. Okay. I've been working on different types of superconducting materials. We have like just to give you some ideas. We have like high TC superconductors. No. So high TC means like their transition temperature is above, yeah, the boiling point of liquid nitrogen. And at the same time, I'm working also on this material, which is it's got the medium TC, yeah, medium transition temperature, so which is around like 40 Kelvin. So I guess those are the different classes of materials here I'm working on. Yeah, but of course, yeah, the one that when we look at those materials, right, it's kind of like complicated because I have like this MgB2, which is a binary compound, right? Yeah, it's got two elements, Mg, magnesium, and boron. Yeah, and I'm the other materials are quaternary. Yeah? We have like transition metal, rare earth, kind of like you have like four components of elements that makes up the compound. Yeah? Okay.
Thank you, doctor. So, next question is from Yanya.
Hello, good morning, doctor. My name is YAKNYAKUMARAN Selvan, and I am first year student of material physics. And I got another question for you, sir. I mean, my first ever question. So, what kind of application does the research have in our daily life?
Okay, applications. Yeah, there are many. Yeah. Briefly, yeah, I'll give you some examples. The first one in transportation. Yeah, transportations. If you look at maglev, yeah, maglev, especially the one in Japan. So the one that levitate the train, actually that material is superconductor. Yeah. So that's a maglev. Yeah, we call it in short we call it maglev. That actually means you have a magnetic levitated train. Yeah? So that's actually the advantage of that is that you actually eliminate, yeah, physical friction, yeah, between the track and the train. So that's why the speed, yeah, the speed record, yeah, for the maglev in Japan, I remember is around 600 kilometer per hour. Yeah. Okay. So that's one, yeah, for transportation. Second, when we look at power transmission, yeah, I mean like those cables like those out there that we can see, yeah, TMV cables, yeah. So superconductors can be made into cables to carry current, electricity, power. Okay, but of course, the challenge is to make a very small scale, very small wires or cables, yeah, for something small scale electronics like your laptop, iPad. That's the challenge. The third, I would say, in the field of medicine, yeah, I'm sure you guys know what is MRI, yeah, MRI, yeah, yeah. So magnetic resonance imaging, yeah. So that is like a must, in every hospital, yeah, for imaging. So the heart of that equipment, uh, you have a superconductor, yeah. So the reason why you need a superconductor for MRI is because the sensitivity to detect changes in magnetic field, yeah. So that kind of high sensitivity, yeah, is superconducting material can show that kind of, yeah, performance actually. Okay, so I guess those are the very popular applications of superconductors. But of course, in Malaysia, uh, I would say, yeah, not many industry are dealing with superconductor, but in overseas they are a lot actually. Okay,
Okay, thank you, Doctor. So I think the next question is from Imran.
Imran.
Okay, hello. Can everyone hear me?
Yes.
Okay. So my name is Muhammad Imran bin Muhammad Fahmi. I'm also from Bachelor of Science of Material Physics. So I want to ask you a question. Okay. So how expensive is it to acquire a material for the research? Okay, that's
Oh, how expensive, yeah. Uh, yeah, we know that, research is basically expensive, Yes. Um, for example, you see, no, for us to synthesize the material, right? So we need chemical compounds, right? Yeah? Commercial one, yeah. So of course, they are these days, you can easily, yeah, purchase commercial available chemicals, yeah. So what I need, right, to synthesize those superconducting material, yes, I need like either oxide or I need like pure elements. Okay. Uh, if you look at like one bottle, it depends on the elements, yeah. If their abundancy is like huge, so which means that material is cheaper, yeah. But if let's say that material is like quite rare, or the process, yeah, to purify the material, yeah, is like complicated, then that also will make, the that compound, the material is like expensive. Okay. um yeah, no, one bottle of chemical compounds like oxide, we are talking about like 50 grams, that can easily cost you 3 5,000 ringgit Malaysia. Okay. Yeah, so if I need like four different types of compounds, right? So then you need like more than 10,000 to purchase those material. So that's not the end of the story. Now with that, those chemicals, right? Then you still need to have a lab facilities, facilities for you to prepare the material, for you to mix those elements, right? Mix them together, and then you need to have we call it as a furnace, yeah, relau, yeah. So this furnace will also cost you money because we are going to heat up the material to like 1,000 degrees Celsius, yeah. So that also consume power, right? Lots of power. Okay, yeah. If you would like to kickstart a small scale research, right? Uh, just to prepare the material, that spend some money to characterize, to do some measurements. I would say at least, you need to have like more than 10K, ringgit Malaysia at least. Okay. So not to mention about what kind of equipments you can purchase, right? Of course, your equipments are even more expensive, You see, for example, in my lab, right, we have this equipment to measure the transition temperature of superconductor. So that machine itself will cost you several hundred of thousand, yeah, ringgit Malaysia. Okay, yeah. Basically, research is expensive. Yeah. Okay.
Okay, thank you, Doctor. So the last question is from me. And my question is, if we were to pursue the same field of research as you, do you think that Malaysia has enough advanced technology for that? Would you suggest for us going overseas, and which country would you suggest?
Oh, okay, yeah. I have to be frank with you guys, okay? In Malaysia, right, yeah, research on superconductors, not many university in Malaysia offer that kind of research. Yeah. Here in UPM, in UKM, University Kebangsaan Malaysia, and the other one is at UITM, yeah, UITM Jungle, yeah, Pahang, yeah. So in Malaysia, these are the only three places, for research on superconductor. Yeah. Of course, no, I have to admit, no, we have a um, constraint in many ways. Yeah. First of all, no, financially, I mean, yeah, like what I said just now, yeah, you do need like money, right? Funding, yeah, to do research. So at the moment, our funding for research is just nice, no, like just enough, yeah. But having said so, yeah, I have to say that the most challenging issue for us, is the equipments. Yeah, we do not have many powerful equipments for measurements. Okay, so that's why if you guys would like to pursue research in superconductor, yes, you can stay in Malaysia, yeah, like what I said, you have like different university that offer that kind of research, but of course, to get yourself exposed, to advanced technology, things like that. Yeah, no, definitely overseas experience would be better. Yeah. Okay, what are those countries that they're actively doing research in superconductor? I would recommend first of all, um, United Kingdom. Yeah, yeah. And United States. Yeah, and also on the Asia side, Japan. Yeah, Japan and China. Yeah. So these are like the major, the major countries. They are actively working on superconductor. One thing, yeah, in Malaysia, right, you may not see many companies, companies dealing with superconductor. To be honest, yeah. But you look at Japan, right? There are many. Yeah. For example, Sumitomo, even Hitachi, yeah, they themselves they also have sort of like a research on superconductor. Of course, many other private companies they are engaging in research on superconductor, and some of them they can even produce some commercial applications. Yeah. For example, high field magnet something very specific for military application and so on, especially in the United States. Yeah. Those companies, they mainly supply the U.S. Air Force, with many of their, applications related to superconductor. But of course, they will not tell you what they do, because this is confidential.
Okay, thank you, Doctor. So I think my question wraps up for today's interview. Thank you for your time, and
Sure.
see you
Thank
in the
you,
next one.
guys.
Thank you.
Okay.
Thank you.
See you next week.
Thank you, Doctor.
Okay,
Thank you,
thank you
doctor.
very much.